friends, I am Vaibhav from Vaibhav E-Learning Academy. Today we are going to start a new topic in Maths, that is Introduction to Euclid's Geometry. In today's video, we will learn about what was Euclid's geometry, what were his axioms and postulates, what are the theorems, and what are the contradictions of the theorems. We will also solve some problems regarding this topic. So let us start. Euclid. Euclid was one of the earliest mathematicians. He is known as the father of geometry. Euclid is known as the father of geometry. Geometry, the term geo means earth and metron means measurement. So measurement of the earth is known as geometry. And what is geometry? The branch of mathematics which deals with angles, dimensions, etc. is called geometry. So, people were interested in geometry from a very long time ago. Even if you take the world history or if you take Indian history, even from the long time ago, from the civilizations, also the structures, the buildings, the houses were organized and planned. They were planned and organized and made. So this shows that people had the basic idea of geometry from a very long time ago. If you take in Egypt the pyramids, they are made up of triangular in shape, pyramidal shape. So their base may be rectangular, the base may be square, the base may be triangular. So it shows that people knew about geometry from a long time ago. The things which we know now, that is a point, a length, or a line, a surface, a cube, these are things we know as a basic. But these things were also unknown during the time, like during a very long time ago. Euclid was the first person who analyzed these data. He wrote a book called The Elements. The Elements. This book had 13 chapters, and he called each chapter as a book. It means it had 13 books. So now, as one book has some amount of chapter, he called each chapters as one book. So he made a book called The Elements, and it had 13 chapters. Chapters were of different things, like the one chapter was for line, one chapter for breadth, one chapter for surface, one for cube, cuboid, etc. So he named everything as one book. So each chapter is equals to one book. He made a book called Elements which had 13 chapters. So it had 13 books. This is the basic idea about Introduction to Euclid's Geometry, and Euclid is known as the father of geometry. Then he made some points, like he made some points, or you can say that he gave some definitions. So he studied many different points in geometry. He gave some terms. First of all, he gave a term which we all know today as point. What is a point? He said that a point is a dimensionless thing. It has no different parts. I'll say about these definitions in detail. He said something about point. He described something about line. He said something about a surface. And he said about cube. He said these main things. Point. Point can be like this. What you see over here is a point, but this is not actually a point. This is something which we are able to see. We are representing it so that we can see this thing. This is not actually a point. A point is very small. Now if I put something like this is also a point, but you cannot see it. It is a point, but you can't see it. here there is one point, you cannot see, but it exists. So anything which has no part is called a point. Line. So if you take 2 points and attach them, you get a line. Surface. If you take many lines, align them infinitely on the top of one another, simply keep on doing like this. So you will get one surface like this. This is a surface. What is a cube? You take so many surfaces, align them in some manner, you will get one solid, or you can say, like instead of cube, you can say solid. These things were given by Euclid. He gave some definitions. So let us see what are those definitions. These are the points which Euclid introduced in his time. In his time, no one knew about point and line and surface and a cube. So first one is, he said that a point has no parts. This was the first statement which he gave. A point has no parts. If I put a dot over here, it will not have any part. It will not have any length. It will not have any breadth. It will not have any height. This is the first one. A point have no parts. Second one. A line is a breadthless length. A line is a breadthless length. What does this mean? It means that if I do something like this, it is having length, but it does not have a breadth. Here it has some breadth, but it is negligible. We are taking it as a negligible amount. So this was the second definition which he gave. A line is a breadthless length. Third definition, he said that the ends of a line are points. So if you take a line like this end is actually one point. This end is also one point. So this is what the third definition which Euclid gave. The ends of a line are points. Then the fourth definition which he gave was, the lines are a connection of many points on it. So the lines are a connection of many points on it. So what does this mean? For example, here there is one point. This is one line, okay? Then this line is made up of many connection of many points. Here there is one point, here one point. There are infinite amount of points in a line. So the lines are made up of points. So you can say like that. The lines are a connection of many points which are spread evenly. Here one point, then here one point, here. So there are many points. The points combine together and make one line. So the lines are a connection of many points on it. Then fifth one. Here he introduced one 2D surface, 2D, which he called as a surface. So a surface is made up of infinite lines. You can say it like this. A surface is made up of infinite line and it has length and breadth. So what is a surface? You take anything like this, okay? It is made up of infinite line. If you take this board, this one line, infinite amount of lines arranged on each other. Line does not have breadth. It only has a length. A line is a breadthless length. But if you take infinite amount of line, then the breadth, they add up to form some amount of breadth. So a surface is made up of infinite line which has length and breadth. This is the length, this is the breadth. And similarly, like a point, he also said that the ends of a surface are lines, which is true. If you take this board, the end of this board also has one line. This is one end which has a line. This is one end which is a line. This is one end which is a line. This is also one end which is a line. So the ends of the surface are lines. And seventh one, which he said about a solid. A solid is a combination, you can say even combination of surfaces. A solid is an even combination of surfaces. So here, if you take one surface over here, then you take another surface, something like this. You attach these both surfaces. You take one surface over here, it will form one solid. And the edges of the edges of a solid are lines. If you take a room, if you take the edge of the room, that is one line. And one part of the room is a surface. This is what his definitions were. First definition, a point has no part. Second definition, a line is a breadthless length. Third one, the ends of a line are points. Fourth one, the lines are collection of many points on it. Fifth one, a surface is made up of infinite lines and has length and breadth. Sixth one, the ends of a surface are lines. And the seventh one, a solid is an even combination of surfaces. These points he gave. Now, Euclid left some terms undefined. What were the undefined terms? Euclid defined these things which are points, what are length. I mean, he defined something, but if you want to define a thing, it has a meaning, and the meanings also have the words which you need to define. For example, a point. Euclid's undefined terms. So, what are the Euclid's undefined terms? For example, point. He said a point has no parts. A point has no parts. Here in the definition, what are parts? He did not define what is this part. Second thing, length. He said length is a breadthless length. Line is a breadthless length. So he did not define what is breadth. He did not define what is length. So he did not define what is point. He did not define what is line. Similarly, he did not define what is a solid. So these are some terms which Euclid thought of defining it. But if you start defining a thing, it has some meanings which you have to define that, and then that thing also has some other meanings which you have to define. So to avoid this much confusion, all the mathematicians made one convention that these things are undefined. It has a meaning, but they are undefined. So this is in the time of Euclid time. This is not recent. Now we all know what is breadth, we all know what is length, we all know what parts over here. But at that time this was a very big discovery. Point, line and a solid. So these are the Euclid's undefined terms. Now we have Euclid's axioms and postulates. Euclid made some assumptions because he did not define actually anything. He just made some assumption. These assumptions are of two types. So axioms and postulates. So basically Euclid made some assumptions. assumptions. He divided these assumptions into two types. One type postulate and one type as axiom. Both things are same thing, but these two are the same things. So first let us see what is a postulate and then what is an axiom. Postulate. Both things are assumptions only. Postulate is the assumptions which are universal truths and are specifically for geometry. So his assumptions were said to be universal truths. They were claimed to be universal truths, and the universal truth which is only for geometry is called a postulate. And what is an axiom? Axiom is the same thing, the assumptions which are universal truth but for entire mathematics. The assumption which are universally truth for full mathematics. These are called axioms. So postulate and axiom. The assumptions which are universal truths, they are called, which are specifically for geometry alone, they are called postulates, and the axioms are the assumptions which are universal truth for whole mathematics, full mathematics, they are called axioms. So Euclid gave 7 axioms and 5 postulates. What are his axioms and what are his postulates? Let us see his axioms, 7 axioms, and his postulates, 5 postulates. Let us see. So now we will be discussing about some 7 axioms which Euclid gave. Euclid's axiom. Let us see what is the first axiom. What is the first one? Things which are equal to each other are equal to the third quantity if the values are same. So things which are equal to each other if the third quantities, if the values are same. If you want to short this, you can say things which are equal to the same things are equal to each other. This is also a definition. Or you can say things which are equal to the same things are equal to each other. Are equal to each other. This is one very basic thing. Each other. So let us take A is equals to B and B is equals to C. This implies that A is equal to C. That is it. For example, take 3 variables, take 3 quantities. Let us take an X person has 10 apples and a Y person has, that X person has 10 apples and Y person has 10 apples. Okay, and a Z person has the number of apples as X person. Okay, so A is equals to B, X is equals to Y, B is equals to C. This Y is equal to the number of apples that X person. So A is equals to C. Basically just the same thing it is. If 10 is equals to 10 and 10 is equals to 10, then 10 is equals to 10. A is equals to B, B is equals to C, then C is equals to A, or A is equals to C. This is the first axiom. This is very basic for us, but at that time it was again a very advanced thing. Second one. If equals are added to the same things, the result is equal. If equals are added to the same things, then the result is equal. If equals are added to equals, then the result is, the whole is an equal. You can say like that. So, for example, A is equal to B. 10 is equals to 10. Here we are introducing one new term, C. Let us suppose 10 is equals to 10. We are introducing one more term. A plus C is equals to B plus C. Let C be 5. Then 10 plus 5 is equals to 10 plus 5. 15 is equals to 15. This is another point which was said by Euclid axiom. If equals are added to the same thing, the result is equal. If A is equals to B, then A plus C is equals to B plus C. This is the second axiom. First axiom, if A is equals to B and B is equals to C, A is equals to C. Second axiom, if A is equals to B, then A plus C is equals to B plus C. This is the second axiom. The third axiom is the opposite of the second axiom. Here we have the same quantity C, but instead of adding, we are subtracting. So third one, we can say, if equals are subtracted from equals, the remainder is equal. These all are a little bit confusing if you read it in the first time, but they all make no sense. They are just the same thing only. Equals are subtracted from equals. Here again we are taking A is equals to B, then A minus C is equals to B minus C. Let us suppose A is equals to 20, then B is also equal to 20. C is 5. A minus C is equals to B minus C. 20 minus 5 is equals to 20 minus 5. 15 is equals to 15. This is the third axiom. If equals are subtracted from equals, the remainder is an equal. This is the third axiom given by Euclid. The fourth axiom is little bit advanced than these things. So, fourth axiom. The fourth one is, things which coincide with each other are equal to each other, or you can say things which coincide with each other are equal to one another or equal. So, to one another. So, let us suppose there is one line, this one, A, B. There is one line in the center point which is C. Here we are saying that AC plus BC is equals to AB. So how can you prove this? Take this AC over here, AC. Take this BC over here, BC. If you coincide them, if you take this AC and put on top of BC, they both are same. So you can say that things which coincide with each other are equal to each other. Coincide means one on top of another if you keep. Congruency. In triangles it is called congruent. So coinciding means if one thing is kept on the another thing, then that is called coinciding. And if they coincide with each other, then they both are equal. So AC plus BC is equals to AB. This is how you can prove. This question we will be doing in the later on in this video. This is the fourth axiom which he gave. The fifth axiom which he gave was always the whole is greater than the part. This is one important one. Fifth one, a whole is always greater than a part. A whole is greater than a part. How? For example, let us take 10. Okay. Now, what are the ways by which you can obtain 10? 1 plus 9 is equals to 10. Okay. 2 plus 8 is equals to 10. 3 plus 7 is equals to 10. 4 plus 6 is equals to 10. And 5 plus 5 is equals to 10. So here, a whole. 10 is the whole. It is always greater than a part. 10 has a part 9, 8, 7, 6, 5, 4, 3, 2, 1. It has these many parts. But if you take two parts, if you add them, then only you get a whole. For example, you take a fruit. For example, if you take an apple, you take a part of the apple, a small part of the apple. Then also the original apple is always greater than the part of the apple. The part of the apple can be the greatest part. See, always part means one part plus one part gives the whole. So even if you take the one part as the maximum, then also if you add them both, that will be only equal to the whole. Then one part is always less than the whole. If you take 36, then 35 plus 1. 35 is still less than 36. If you take 100, you get 99 plus 1. 99 is always less than 100. So this is one axiom. A whole is always greater than a part. These all axioms were given by Euclid in his own time, so these were also considered very advanced level. Now, as we did with addition and subtraction, the same thing he explained with multiplication and division. Sixth axiom. If equals are multiplied to equals, then the product is also equal. If equals are multiplied to equals, then the product is also equal. That is also one of the axioms given by Euclid. If you want to say equals are multiplied to equals, or you can say if the equals are doubled or if they are half. This is the correct statement. If the equals are multiplied to equals, then the product is also equal. If A is equals to B and C is a constant, so AC is equals to BC. This is a correct statement, but according to the books, according to all the reference material, if equals are doubled, then the product is also doubled. The statement which I wrote is the exact one, but if equals are doubled, the product is doubled. This also you can say, or if you can say that if the things which are double, the same thing, are equal to the same thing. Of equals are doubled, the product is also doubled. For example, A is equals to B. If you double A, then you get 2A is equals to 2B. Just the same thing. Equals are doubled, product is also doubled. Similarly, if equals are half, product is also half. That is the seventh axiom. These all are very boring axioms which are given by Euclid. Postulates are a little bit interesting one, especially the fifth postulate. So wait for that one. Seventh one. If same thing, if equals are divided by equals, which is C, if the equals are divided by any specific equals, then the product is also an equal. But here, according to the books, if equal is halved, the quotient, or you can say the answer, is also halved. So if A is equals to B, then A by 2 is equals to B by 2. These are the axioms which are given by Euclid. Things which are half of the same things are equal to one another. If equal is half, the answer is also half. Same thing, how many ways if you want you can express it. These are the axioms of Euclid. Now let us discuss the 5 postulates about Euclid. Let us see. We will be discussing about some postulates given by Euclid. He gave basically 5 postulates. Each of the postulate. Now here postulate is the rule, or you can say postulate is the assumption which are applied or limited only till geometry. So first one is a straight line can be drawn from any point. A straight line can be drawn from any point to another point. A straight line can be drawn from any point to another point. For example, there is one point over here, there is one point over here. You can draw a straight line from here to here. Okay, there is a point over here, point over here. You can draw a straight line. There is a point here, there is a point over here. You can still draw one straight line. So any 2 points can be connected by using a line. This was the first postulate which was given by Euclid. Second postulate is terminated lines can be produced infinitely. So what are terminated lines? The lines which we are drawing from this point to this point, this is one line which is terminated. If you want to produce this line, this can keep on going permanently. This will also keep on going permanently in either of the direction. So terminated line can be produced infinitely. This is the postulate number 2. Postulate, it is applied only to geometry. Third one. A circle can be drawn from any center and radius. For example, I decide one point over here, this should be my center and this much should be my radius. I can easily make one circle. If I decide this should be my center, this should be my radius, I can easily make a circle of that radius. If this is my origin, this is my radius, this can be my circle. So this is the postulate. A circle can be drawn from any center and any radius. Then the fourth postulate, all right angles are equal. Exactly. All right angles are equal. Right angle means 90 degree. This is a 90 degree. This is 190 degree. This is 190 degree. This is 190 degree and this is 190 degree. This is 190 degree. These all are 90 degree. All the right angles. This one right angle, right. Every right angle is equal. This is the fourth postulate given by Euclid. These are the 4 postulates. There is one more postulate, fifth postulate, which is one important one. So for that, let me write the definition first and then I will explain you what is that postulate. So now we have the fifth postulate over here. If a straight line falling on 2 straight lines make the interior angles on the same side of it taken together less than 180 degree, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 180 degree. If a straight line falling on two straight lines, let us take two straight lines, one like this, one like this. One straight line is falling on two straight lines. A straight line falling on two straight lines, make the interior angles on the same side of it. Interior angles are this and this, here this and this. They are on the same side, yeah, here and here. Of it, taken together less than 180 degree. So, if it is parallel like this, then this is 90 degree, this is 90, this is 90 and this is 90. But 90 plus 90, here 180 degree, here 180 degree. If it is taken together less than 180 degree, then the two straight line, if produced indefinitely, meet on that side. So just remember this. Here there is one theta, here there is one theta. So if you see this, which side the angle is less, you take this one and divide it into two parts. This is like A bar, no, A, B, this is C, D, this is P, Q. Divide this into two parts, ACPQ and DDPQ, okay? This part and this part. Check which side the angle is less. For example, here, take a perpendicular like this, okay? Over here. See here which side it is more than 90 degree. Obviously this side. You take this from here and if you see this is more than 90 degree, this is less than 90 degree. This side also, this is supposed to be the normal. This is supposed to be 90 degree, but this is theta times more than 90 degree. This angle is more than 90 degree, this is less. So if you project them infinitely like this, at one point here they are meeting. But in the opposite, they are never going to meet. They will go somewhere else. They will diverge, but here they are converging and meeting at one point. Wherever the theta is less than 180 degree. This 90 and this 90 combine to make 180, this 90 should combine to make 180 degree. The side in which these angles are not making 180 degree, they are making less than 180 degree. Side of it taken less than 180 degree, if you project that side, they will meet at one point. This is one very important, very interesting postulate of Euclid. So, this normally what is the case? This is one parallel line. Here you draw one perpendicular. This side 90 degree, this side 90 degree. This 90 plus this 90, 180. This 90 plus this 90, 180. But if there are two lines, something like this, then this theta is not 90 degree. Okay, it may look like 90 degree here because I have drawn it like this, and then like this, and something like this. Then this side is less than 180 degree if you combine them totally. Suppose this is 60 degree and this is 30 degree. This is how much? 120 degree? No. This is 60 degree. This is 120 degree. This is 60 degree. Suppose like this. Or this you can take more than 90 degree, right? 120 degree. Here it is 30 degrees, 60 degrees, something like that. Both should be equal to 180 degree if it is straight. But here, this side, it is less than 180 degree. So if you project that side, they will meet at one point, and here they will keep on going further. This is the postulate of Euclid. If a straight line falling on two straight lines make the interior angles on the same side of it taken together less than 180 degree, then the two straight lines, if reduced indefinitely, meet on that side on which the sum of angle is less than 180 degree. These both sum is less than 180 degree, so they will meet at that point. So this is the Euclid's fifth point. So there is one more thing. If the Euclid is like these are the axioms, these are his postulates, they should have some consistency. What is the meaning of consistency? If you are using these axioms to make one theorem, what is a theorem? I will explain about theorem just in a second, but consistency should be maintained. If you are taking that axiom and you are trying to prove something else, another thing, you're taking that axiom and trying to prove something else, if that thing contradicts with the axiom, like contradiction in the sense it is going opposite of the way it should go. You have to go left, but you're going right. You're contradicting your main path. So, if the law, you are making something, you are using that axiom, and if you are doing something which the axiom is opposing, then that is not said to be truth, because axioms and postulates are considered to be universal truth. If you do something against that axioms, then whatever you are doing is wrong. Similarly, along with axioms and postulates, given the theorems. What are theorems? Theorems are the statements which are proven by axioms. The statements which are proven by axioms are called theorem. One very famous theorem we have, that one of the theorem which is given is that two distinct lines can never have more than one meeting point. So suppose there is one line L, this is one line M. These both will first of all either meet or they will not meet. If they will meet, they will have only one common point, which is like this, L and M. This is a point P. Okay, how will you prove that this is a theorem? So according to this theorem, two distinct lines can never have more than one meeting point. You can imagine this. This is not possible to illustrate here, so you have to imagine here. Imagine that there are two lines which are meeting and they have two same points, P and Q. P and Q lies on L, P and Q lies on M. This is not possible to actually draw. This just you have to imagine. Imagine two lines are meeting and they have two common points. What did the axiom say? One postulate said that any line can be drawn from any point from one point to another point, right? This is contradicting that point. It said that the axiom is saying that there is only one, the axiom is saying that only one meeting point is there for two distinct lines. But we are imagining that there are two meeting points, which is wrong. Our imagination is wrong because theorem has been proved by axioms. So whatever we are thinking is wrong. This is the theorem. Two distinct lines can never have more than one meeting point. This theorem is proven by some axioms. So you cannot say this theorem is a wrong theorem and etc. So now let us move on to some questions. Some questions which will describe this theorem, and we will be using some axioms and postulates to prove them. Let us see. So now we have a question over here. If AC is equals to BD, then prove AB is equals to CD. So this we have to prove that AB is equals to CD. We have been given that AC is equals to BD. Okay. We have to find AB. Now we know AC, we know BC. So here, if we take AC minus BC, you will get AB. Okay, listen. Then BD. We have to get CD from BD. Okay, BD. This is BD. If you take BD and subtract BC, you will get CD. BD minus BC is equals to CD. Now, which axiom this is? If equals are subtracted from equals, then the results are equal. See, we are taking a common subtractor, BC. This is common in both. So, if A is equals to B, then A minus B is equals, A minus C is equals to B minus C. This axiom we have to use over here. So, using the axiom, we have to write full statement, but I am writing in short. Using the axiom, A is equals to B, then A minus C is equals to B minus C. A minus C is AB. We get A minus BC is what? AB is equals to B minus C is equals to CD. Thus we prove that AB is equals to CD. This is how the model questions will be coming. This is one of the example question. Now after the Euclid's fifth law, we will come back to the fifth postulate. After the fifth postulate, there are many equidistant postulate related to Euclid's fifth postulate. One of the famous postulate was given by John Playfair. He is a Scottish mathematician. He said that this is one line, say AB, say CD. They meet at a common point P, then there can be no another line C which is parallel to both. This is very common thing. If there are two lines intersecting each other, there will be no third line which will be parallel to both. This was given by John Flymare, which was given by actually John, who was a Scottish mathematician, given by John Playfair. He was Scottish mathematician. He redefined Euclid's fifth postulate. He said that if there are 2 points, 2 lines which are intersecting at a point, then they cannot have any third line C which is parallel to both AB and BC. This was all about Euclid's geometry. So this whole chapter covered in one video. I hope you have enjoyed this video. If you enjoyed this video, like this video, please subscribe to this channel if you find this informative. Share this with your friends. See you next time in the next video. Do subscribe, press the bell icon so that you can be updated with the new videos notification. Thank you and goodbye.